Welcome. Today's content is about statistical pattern recognition. We are going to see about the Bayesian theorem. So we consider the classifier h of x is equal to 0 if q naught of x is greater than q1 of x, which means if q naught is higher itself, the output class is 0. If q1 probability is higher, it belongs to output class 1. Such classifier minimize the probability error in the classification. Fi of x is the probability density function or the conditional joint density function. Pi being the probability of y of x belongs to y is called the prior probability. Probability occurring for the particular class. So it's prior probability. We know the previous occurrence of the event. Qi of x is the probability called posterior probability. Bayesian theorem states that Qi of x is equal to the posterior probability is Fi of x, the probability density function, into Pi, the prior probability, divided by the likelihood function Z. Z is equal to f naught x p naught plus f1 of x p1. It's a normalizing constant, likelihood function. So under the classifier given, 0 if q naught is greater than q1 and 1 greater than 1 if q1 is greater is called Bayes classifier. So other classifier has low probability error than Bayes classifier, and it's an optimal classifier for multi-class problem. So Qi of x will be the same equation, Fi of x into Pi by Z, where Z is sigma I equal to 1 to L for all the classes, Fi of x into Pi, where L is the number of classes. So we have a problem for that. So there is a frequency table given here for a weather forecast. So the problem is here, frequency table for a sample weather data set. Play golf is the output variable and outlook is the input variable. Outlook has 3 attributes, sunny, overcast and rainy. Play golf has 2 attributes, yes and no. So what is the conditional probability for all we need to find? So outlook, sunny, yes is 3, sunny, no is 2. So we need to find f1 of x conditional probability given that sunny and yes. So it is 3 by 3 plus 4 plus 2, which is 9. So it is 3 by 9. If not for conditional probability for sunny, no will be 2 by 2 plus 0 plus 3, which is 2 by 5. In this way we write the f1 of x and f0 of x for yes and no for all the 3 outlook variables, sunny, overcast and rainy. So yes is 1 and no is class 0. So yes class is total 9 and no class is total of 5. And the total possibilities we do is 14. So this S class is prior probability of S class Pi is 9 by 14 and prior probability for no class is 5 by 14. P naught is the prior probability for occurring of a class no, which is 5 by 14, and P1 prior probability for occurring of a class 1 is 9 by 14. Bayesian theorem equation, we have Qi of x posterior probability equal to the probability density function into prior probability divided by the likelihood function. We need to find Z, the likelihood function, which is f0 of x p0 plus f1 of x p1. f1 of f0 of x is, we have it here, 2 by 5 for sunny and 5 and P naught is 5 by 14 plus F1 is 3 by 9 for sunny, right, into 9 by 14 is this P1, and we find it to be 5 by 14 is that for sunny we have found. Same way we find the posterior probability Qi equal to Fi of x. So F1 of x is 3 by 9 into P1 9 by 14 divided by the Z value 5 by 14. So we have the value answer 0.6. And same way we find for Q naught class 0 probability of class sunny and no. So it would be F1 F naught, right? F naught of x is 2 by 5 into P naught is 5 by 14 divided by Z value, we get 0.4. So here Q1 is greater than Q0, and so as per Bayesian equation theorem, it belongs to class 1. Yes, class yes. Class 1 is yes. Q1 is greater than Q0, so it belongs to class yes. Same way for overcast and rainy, we find the Z values Q1, Q2 and find the class values. So it's about the problem for Bayesian classification. Thank you.